Welcome back to the next lecture of satellite communication. So let us discuss what we discussed in the previous lectures. Particularly, we discussed how we can find the location of a satellite. If we consider the Earth station, then the line joining the center of the Earth and the satellite intersect to a particular point on the Earth's surface, and we call that particular point as the subsatellite point. And we discussed if we are looking from satellite to Earth, then that direction is called nadir. If we are looking from Earth to satellite, then that direction is called zenith. And if a satellite, always satellite position can be uh, represented by the coordinates, that is by latitude and longitude. So when it is represented by latitude and longitude, so this is the latitude and longitude of the subsatellite point. Okay, so suppose the latitude and longitude of a satellite is given, so it is understood that this is the latitude, whatever value is given, this is the latitude of sub-satellite point. So that is the line joining between the center of the Earth and the satellite. So where that line intersects on the Earth's surface, so that coordinate is the coordinate of the satellite. Okay, and if a satellite, if for a satellite only the longitude is given, that means you see here 83° east it is given. It has no information about the longitude. Oh, sorry. It has no information about the latitude, only the longitude is given. So in that case, you have to assume that it is an geostationary satellite. Okay, GEO satellite. So by default, the latitude of this satellite is 0° latitude. Okay, and the longitude is given 83° east. So hence we discussed that GSAT-3 is a geostationary satellite. Now take an example. It is given that a geostationary satellite at 87° east and a location is given. Suppose this location is Bengaluru. Okay, this location is Bengaluru. So the location of Bengaluru is 22° north, 87° east. And the question is the sub-satellite point will be dash of Bengaluru. Okay, options are right on Bengaluru, south of Bengaluru, north of Bengaluru, and east of Bengaluru. So what is, try to understand the question or analyze the question. A geostationary satellite is at 87° east. Okay, so see, only the longitude is given, latitude is not given because it is a geostationary satellite. So geostationary satellite means the latitude will be 0° north or 0° south. Okay, the longitude is 87° east. Okay, so what is given, what this coordinate is about? This coordinate is which coordinate? It is the satellite coordinate. In other way, this is the coordinate of sub-satellite point. Getting the point? Okay, let me go to that previous figure where I had represented a globe. No, it is not here. Okay, let us see here also. What is given? The satellite is at 87° east. Okay, that means 0° latitude. That means it is an geostationary satellite. Okay, and what this line? This is the longitude, and this longitude is 0° longitude. So all the longitude in this direction will be east. All longitude in this direction will be west. Okay, in our question it is given 87° east. Okay, so that longitude will be suppose this one. So this longitude is 87° east. I have assumed, I don't know whether it is that longitude or not, but I have assumed this longitude is the 87° east longitude line. And the dotted line represents the equatorial line. Okay, and our satellite is a geostationary satellite. So the orbital plane is having 0° inclination to the equatorial plane. Okay, so both the equatorial plane and the orbital plane, they are matching. Okay, or both the planes are having the similar, both are the similar planes, right? So that means this is the sub-satellite point. Okay, assume that sub-satellite point is always on the surface of the Earth. It is not located in the space. Your satellite is in the space, but not the sub-satellite point. Sub-satellite point is on the surface of the Earth. So sub-satellite point is the line joining between the center of the Earth to the satellite. Where it intersects, that is called the sub-satellite point. So the coordinate, whatever the coordinate of the satellite, that is nothing but the coordinate of the sub-satellite point. So this is the sub-satellite point. You can see it is lying on the equator, and it is also lying on the the longitude, that is 87° east longitude. All right. Now, what is there in the question? Question is, and Bangalore has a coordinate that is 22° north, 87° east. Okay, the coordinate of Bangalore is given, that is the latitude is 22° north. Okay, come back to the previous, and 87° east. So Bangalore is located. What is the longitude of Bangalore? Longitude of Bangalore is 87° east. Okay, so this is the longitude. See, both the longitude are having same. The satellite longitude and the Bangalore longitude, both are same. That means the Bangalore city is lying somewhere on this particular longitude. In between this point to this point, the city Bangalore is somewhere. Okay, but do not forget about the latitude. The Bangalore is having a latitude also, that is 22° north. So 22° north means it is Bangalore is present above the equator. Okay, so this dotted line represents the equatorial line and where the sub-satellite point is located. But Bangalore is 22° north. So 22° north means, let me take another color. So 22° is somewhere here, this particular. So you see, this is the 22° latitude. This line represents 22° latitude, and this red line represents 87° east longitude. So this latitude is 22° north latitude. Okay, north means it should be above the equator, and this red color line represents 87° east. East means it is towards the east direction of the 0° longitude. So where these two lines, that means this red line and this green color line intersects, so that is the location of the city Bangalore. Okay, so this particular point represents your city Bangalore. All right, and this particular point which is located on the equator and 87° east. This is your sub-satellite point, or this is your location of satellite. Okay, now come to the question. The sub-satellite point will be dash of Bengaluru. It is right on Bengaluru. That means both the sub-satellite point and the city Bengaluru. So both are lying on the same point, or the sub-satellite point will be south of Bengaluru, or the sub-satellite point will be north of Bengaluru, or the sub-satellite point will be east of Bengaluru. What is the right answer? You see this diagram. The sub-satellite point is here. This one, it is south of Bengaluru. Is it or not? This is the southward direction. So the correct answer should be south. Yeah, the correct answer is south of Bengaluru. So this is one example. If the coordinate of the sub-satellite point and any particular point, or that is called the ground station location, will be given, so you can already find out what is what is the exact location of the ground station and what is the exact location of the satellite. So means your satellite is located at which direction from the with respect to the ground station, like that you can find out. Okay, so now let us look at a different case. It is asked, what will be the trace of sub-satellite point on the Earth for a GSO satellite? Okay, so GSO means geosynchronous. GSO satellite means geosynchronous satellite with non-zero inclination. Okay, so try to understand. It is a geosynchronous satellite and non-zero inclination. If I will ask, zero inclination means it will become GEO satellite. That means geostationary satellite, because geostationary satellites are having 0° inclination with respect to the equatorial plane. And since it is given non-zero inclination, okay, non-zero inclination means the geosynchronous orbit is somehow inclined with respect to the equatorial plane. You see here, the thick black line represents the equatorial plane, and this red color, this represents the orbit, and this orbit is called GSO orbit or geosynchronous orbit. But this orbit is not the geostationary orbit. Okay, your geostationary orbit should be inclined or 0° inclined with respect to equatorial plane. So this is not 0° inclined. It is non-zero inclination. So your satellite is rotating like this. Correct. So one property of geosynchronous satellite is the geosynchronous satellites, they are moving at a velocity that is equal to the velocity at which the Earth is moving around itself. So velocity of the Earth is same as the velocity of geosynchronous satellite. That means the sub-satellite point and the satellite both will remain at, that means it will remain same. So both will face with each other. Okay, that means the relative motion in between any surface on the or any point on the surface of the Earth with respect to the satellite, the relative motion will be zero. I repeat, in case of geostationary orbit satellite, the relative motion between any point on the surface of the Earth with respect to the satellite is zero, because they will not move, they will be stationary. Correct? But since the inclination is given, so it has been asked of what will be the trace of subsatellite point. What will be the trace? Trace means whether the subsatellite point will remain at a particular point or the subsatellite point will change. That is the question. The subsatellite point will always remain fixed or the subsatellite point will change. In case of a geosynchronous orbit satellite having non-zero inclination. Okay, now look at this particular diagram. So this dot, this blue color dot represents the location of the satellite. Okay, now the satellite is moving in this direction. All right, it is moving in this direction, and your Earth is moving in this direction also. Around itself, the Earth is also rotating. Understood the point? Now you see this at this point, you see the satellite is located north of the equator. Is it or not? The satellite is located north of equator. Then when the satellite goes from this point, okay, and this point will turn to backside. Now compared to this point, with respect to when the satellite was earlier here, this is a reference point which is on the surface of the Earth. So with reference to this point, the satellite is located towards north. Now satellite is moving and the Earth is moving, so both are moving. So when this point moves to backside of the Earth, so this point will be located here, but that should be in backside, which is not visible to us. And at the same time, your satellite is also moves to that backside. At the same time, your satellite will also reach to the backside. And at that particular point, what will happen? The satellite will come to the plane of equator. Okay, it will come to the plane of equator. That means the satellite will lie on the equatorial plane, which is not visible here, or it is difficult to imagine, but here you can imagine. Now, the when this particular point moves to backside, then what is the angle of rotation? Your Earth has moved 90 degree. When the Earth moves 90 degree, then this reference point comes to the backside of the Earth, which is not visible to us. Now, when this point rotates 180 degree, then this point comes to this point after completion of 180 degree rotation. So this reference point will come here. Now, where this satellite will come? This satellite will come here. Because both are moving and both are moving at the same velocity. So if you notice here, what is the location of the satellite with respect to this reference point? Now the location of the satellite will be south of this reference point. And what about the subsatellite point? Subsatellite point will be the line joining between the satellite and the center of the Earth. So this line, if we join, so this is the subsatellite point. Understood? So in that case, what happens? The subsatellite point has come to south of this reference point. Okay. In case of 180 degree rotation, the subsatellite point will be south. Now, first of all, when it is 0 degree rotation, what is the location of subsatellite point? You see the line joining between satellite and the center of the Earth. So this is the location of subsatellite point. This is the, if you join the line, so this is the subsatellite point. The subsatellite point now is located north of this reference point. Now, after 180 degree rotation, the reference point has come to this end and your satellite has come to this point. So in this case, if you make a line joining between the center of the Earth and the satellite, the sub-satellite point will be here. And in this case, the sub-satellite point will be south of this reference point. So at this point, it is north. The sub-satellite point will be north. At this point, the sub-satellite point will be south of this reference point. And that is why I expect when it makes 90-degree rotation, that means 90-degree rotation means when the reference point is backside of the Earth, which is not visible to us because we are this side in the front. So at that time, the sub-satellite point will lie on the equatorial plane. That is what I am guessing, and that is my guess is also correct, which you also can verify. After 180-degree plus 90, it will be 270-degree. So after 270-degree rotation, the satellite will come here. So this is 270-degree rotation. The satellite will come here and the sub-satellite point will be here. So that means this particular point, this particular point is lying on the equatorial plane. Okay, so what we observe that sometimes the sub-satellite point is north, sometimes it comes on the equator, sometimes it goes to the south, again it comes to the equator, again it goes towards the north. So this is the movement of the sub-satellite point. So what is the trace? If you want to make a trace or the movement of the sub-satellite point, the trace will be like this. See, sometimes the sub-satellite point will be here, then it comes to the equator, then it goes towards south, again it comes to equator, again it goes to north, like this. This is the trace of the sub-satellite point. Okay, understood how it is happening. Now, any question now? Yeah. Now let us have some other discussion how we can find the range of the satellite. Okay. So range in the sense at what distance the satellite is located. So before doing that, we will come across different terminologies related to that. One is called the elevation angle. Another is called the azimuth angle. Okay. So this is the cross section. This is the cross section of Earth geometry. Now your satellite is located somewhere here or in the sky. So this direction is north direction. This direction is southward direction. This direction is eastward direction. This direction is west direction. Okay. So this you can see these particular lines are the latitude lines and these particular lines are the longitude lines. That means the lines from north to south, these are the longitudes. The lines from east to west, these are the latitudes. All right. So what is elevation? Elevation angle is the angle of inclination. That means from the plane, how much angle the satellite is making towards the center. So this angle is called inclination angle. Okay, your satellite is here in the sphere and the surface you are seeing here, this is the equatorial surface. That means you take your Earth is a complete sphere and you just exactly make a half piece or you cut it into two parts exactly at the equatorial line. Okay, you take your Earth and cut the Earth at the center, at the equatorial line. If you cut the Earth into two pieces, two equal pieces, so this plane, this is the plane you will get. So this direction is north and south, east and west. So your satellite is located somewhere here. So this is the location of your satellite, and this angle from the plane or the equatorial plane to the inclination angle is called the elevation angle. All right. And what is azimuthal angle? Azimuthal angle is always calculated from the north towards east direction. Always remember the azimuthal angle is calculated from north towards east direction. Okay, so don't consider that this angle is your azimuthal angle because this direction is west, because this is west. Okay, so this is wrong. Towards east because this is east. So from north to east direction you have to calculate. So this angle, which is marked by red color ink, your this angle, whatever this angle will be, that angle is called the azimuthal angle. Yeah, this is what I have mentioned here. Azimuthal angle, it is the angle from north to subsatellite point. Okay, so this point is the subsatellite point on the horizontal plane with eastwise movement. Okay, let us see by taking an example, we will see how we can calculate the range and look angle of the satellite. So see here, this circle represents the your sphere, the Earth, and this is the S represents the satellite. Okay, this E represents the your what your ground station. Okay, and C represents the center of Earth. So this line joining the satellite to the center of the Earth intersects a point on the surface of the Earth. So that is called subsatellite point. Okay, so now from the center of the Earth to any point on the surface of the Earth, that distance is called the radius of the Earth. Okay, from C to this point or C to this point or C to any point which is on the surface of the Earth, that distance is called the radius of Earth. Now RS is called the uh, RS is called the orbital height. Okay, RS is called the orbital height of the satellite. So that is the summation of RE plus RS, where RE is the Earth radius. Okay, you can see from this point to any point on the surface, that is your RE plus this. So that means this is RE and this distance is H. So H is called the altitude of the satellite. So altitude of the satellite is from the surface of Earth at what distance the satellite is located. So that distance is called the altitude. Okay, so altitude and orbital height are two different parameters. RS represents the orbital height, H represents the altitude of satellite. Because your satellite is rotating in an orbit. So that orbit can be a circular orbit or it can be an elliptical orbit. So when we talk about the orbital height, so orbital height will always be calculated from the center of the orbit. So here, since your Earth is there, so center of Earth is nothing but the center of the orbit. Okay, so that is the center. So that's why RS is called the orbital height, whereas H is the altitude of that satellite. That means from the Earth's surface at how much distance the satellite is located. D is the distance between the Earth station to the satellite. Okay, so any antenna or one Earth station is located somewhere here. From that to the satellite, this distance is called D. So that is called the satellite range. Okay, so this IE is called the longitude of your Earth station. Or no, it is not. It is called LE. not IE. LE is the longitude of Earth station. So here is the Earth station. Your Earth station is here. So this particular line, if you note, this is the longitude line. Okay, this line is the longitude line. So this is the 0 degree longitude. This one I will write here. This one 0 degree longitude. Which one? This one, the straight line. So from this, how much it is towards east? So it will be LE is the longitude. Capital LE represents the latitude of Earth station. Okay, this is the Earth station. So this Earth station is located at what latitude? So that is represented by capital LE. Small ls represents longitude of subsatellite point. So this is the subsatellite point. The longitude, that means it will be this much up to this. So this one is the longitude of subsatellite point, because the subsatellite point is lying on which longitude? It is lying on this longitude. Okay, so from this point to this point, so this value will give us the small ls, that is the longitude of subsatellite point. Similarly, ls, capital Ls, it will give you the latitude of subsatellite point. This is the subsatellite point. So from this to this, that means this to this will be the latitude, because this particular, this is equatorial line. This line is the equatorial line. So 0 degree latitude. So from 0 degree to how much it is, so that gives us the capital Ls. So that is the latitude of subsatellite point. Now, this angle we have given, I suppose this angle is represented by gamma. This angle we have represented by eta, sorry, this psi. All right. So now if you see in this triangle, CES triangle or SCC triangle, by using the triangle law, we can write this side d square is equal to RE square plus RS square minus 2 into RE into RS into cos gamma. This is the property of the triangle. And we also can write d divided by sine gamma. So this side divided by the angle, and RS, that means this axis divided by this angle, sine of this angle. So d divided by sine gamma is equal to RS divided by sine psi. That is also equal to RE divided by this angle. But since we are no more concerned about that, that's why we are not writing. So we write only d divided by sine gamma is equal to RS divided by sine psi. Okay. Now see here, what is this psi? Analyze, this is your earth. Okay, so this particular straight line is what? It is the line joining from earth, from your earth station to the satellite. Okay, and this is the line joining from the center of the earth to the earth station. So earth station is always located on the surface of the earth. So that means it is the line joining from the center of the earth to the earth surface. That means it is by default the radius of the earth. All right. So this angle psi, but what it is, I will draw here for more clarification. Just analyze this very carefully. You analyze. Okay. So this is the point where your satellite is located. And this is your ground station. that is denoted by E. Okay, you see E is on the surface of the ground, so I have kept E on the surface of the ground. Okay, so what is ES? It is, I will combine this ES and this point is C. So this is my triangle. And this angle is the psi. Understood? So this angle psi, I can write if I draw one tangent, if I draw a tangent on this surface, so what this angle? The angle between EC and the tangent, this angle will be 90 degree. Okay, this angle will be 90 degree. Which angle? I am drawing it on a bigger diagram. So this angle is your psi, but this angle is 90 degree. So what about this angle? This angle is your elevation angle. If you look back to the previous slide, yeah, you see how much means at what elevation angle the satellite is present. So that is the elevation angle. So this angle is elevation angle. So that means I can write psi is equal to 90 degree plus elevation angle. Hope it is understood to all. If no, you can ask me. So in place of psi, I can write it here. This psi is equal to 90 degree plus elevation here only. So sine 90 degree plus elevation will be cos elevation. So sine psi is equal to cos elevation. Now, in place of sine psi, I can write here as cos elevation. Okay, so now by using cross multiplication, I can write d cos elevation is equal to rs into sine gamma, and cos elevation is equal to rs sine gamma divided by d. That is what I have written. It's very simple. By cross multiplication, this will be, this denominator is now cos elevation. So d cos elevation is equal to rs into sine gamma. So cos elevation is equal to rs into sine gamma divided by d. So that is what I have written. So this is, don't forget, look at this number. It's my page number. All right. So in this case, I got the cos elevation. So see one thing. In this case, RE is the radius of the earth, which is known to us, that is 6,378 kilometer. RS is the orbital height of the satellite. And if you take the satellite as a geostationary satellite, then the orbital height is also known to us, that is around 36,000 kilometer. The exact value is 35,000 something. Again, RE and RS known, so only unknown is gamma. So once we can find out the value of gamma, then we can find out that what is the distance between the Earth's surface to the satellite. So this distance or the range of the satellite can be obtained. So do not be confused on D and RS. Not RS, H. So the distance between sub-satellite point to the satellite, that is your h, or that is called the orbital height. So d is different. D is, suppose you are located, uh, let me draw here. This is your Earth. This is the satellite. The satellite has a coverage from this point to this point. This is the center of the Earth. So if you make a line joining from the center of the Earth to satellite, this point is the sub-satellite point, and this point to this distance is your radius of the Earth, and this point to this point, this distance is your your altitude of the satellite. That means at what height the satellite is present from the surface. Okay, but assume there is some ground station which is transmitting information. So from ground station to this distance we have denoted by d. Okay, so do not think that d and h are same. Okay, they are different. So d is, suppose there is a ground station which is communicating with the satellite. So from ground station to the satellite, that distance we have denoted by d. Whereas h is different. H is the distance between soft satellite point to the satellite. All right. So once we know the value of gamma, then only we can find out at what range the satellite is present from the ground station. All right. So here we obtain the value of cos elevation like this. Now, you see, now here cos elevation is what? Rs divided by d into sine gamma. Okay, cos elevation is equal to Rs by d into sine gamma. Can I write this as sine gamma divided by d by Rs? There is nothing wrong in writing this way also. In the numerator, I have kept sine gamma, and in the denominator, I have kept d divided by Rs. So sine gamma divided by d by Rs is equal to Rs by d. So that's why Rs will be multiplied and d will be in the denominator. So there is nothing wrong in writing this way. Okay. So what I will write, cos elevation is equal to sine gamma divided by d by Rs. Okay. So this what I will write, cos elevation is equal to sine gamma divided by d by Rs. All right. Now come back to this particular slide. We have this equation. Now divide this left hand side by Rs, right hand side by Rs. No, Rs square. We will divide by Rs square. So what it will be, d square by Rs square, or d by Rs is equal to square root of what is square root of Re square by Rs square plus this will be 1 because it will cancel, minus Rs, and it is Rs square. So it will cancel 2 Re by Rs, 2 Re by Rs into cos gamma. So d by Rs we got this value, so which we can put there. So you remember what we got, d by Rs is equal to 1 plus Re by Rs square minus 2 Re by Rs cos gamma square root. So this is what d by Rs. In the denominator we got 1 plus Re by Rs square minus 2 Re by Rs cos gamma to the power 1 by 2. That means it is square root. Okay. So this is what again I am showing you. Just see d by Rs, because I want to replace this value d by Rs in the denominator. Okay. So I obtain d by Rs, this 1 plus Re by R square minus 2 Re by Rs cos gamma. So 1 plus Re by Rs square minus 2 Re by Rs cos gamma and square root of that, because 1 by 2 means square root. So this is the value of cos elevation I got. Now let us take some assumption, that is assume that the radius of the earth is 6,000 kilometer, because the exact value is 6378. 6378 kilometer is the exact value of earth radius. And Rs is what? Orbital height. I told you this is Rs. Rs means from this point to the satellite point. Okay, so that is equal to 42,000 kilometer around, or it is 41,000 something. Okay, but this one is different. From this point to this point, it will be 35,000 something, or which is approximately 36,000 we are taking. So 36,000 means sub satellite point to satellite, that is 36. But Rs is, it is the summation of this 36 as well as the earth radius. So that is the Rs. Now, if we these are the constants, if you put this here in this equation, now your equation will be in form of gamma. So cos elevation will be only this value. All right. So you have the cos simplified expression of cos elevation by using the predefined value of Re and Rs in this equation. Okay, so the next calculation, finally what we are going to see, we are going to find at what range the satellite is present in the next discussion. So due to short of time, I like to stop my lecture here. And if you have any question, then you can ask me. I will be happy to answer your question.